So the first part contains only the information about the relational model. So without any of the higher, much more detail, what is the structure of relational databases, how to define the database schema, what is meant by keys, how to represent the schema diagrams, and relational query languages. And after covering these points, so these are the starting basics. And after that, we are going to see three more languages in this chapter. Three languages. First one is relational algebra. Next one, tuple relational calculus, and next one is a domain relational calculus. So these three languages are procedural and non-procedural languages. So we are going to have examples as well as some few examples we will solve as a practice during the lecture, and few might be given as a assignment to you or homework to you. And next comes the major part of the database system, that is structured query language. So if we are having almost 10 implementations, out of that 8 implementations use SQL as a primary means. It means our 8 implementations are based on this remaining part of the syllabus. So this chapter might quite learn for our 2 hours lecture as 8 to 7 to 8 lectures. So we will try to cover maximum examples for the SQL, and then only we will proceed for the next chapter. But this chapter is much more important, and this chapter is covering maximum questions of your uh, technical interviews, etc. Because if you are dealing with the database is a core branch of the computer, and that's why here SQL is also considered as much more part. First part is keys, and afterwards keys, the SQL is the next part on which maximum questions can be asked. So this chapter is going to learn very lengthier. So let us see first details, and almost 7 to 8 lectures might be requiring, that is 2 hours lectures. So let us start with the first point, structure of relational databases. So here in case of second chapter, ER model, so we are having entity and relationship. And to show the relationship between the different entities, we are using the relational concept. But this graphical structure was not storing any kinds of data. Only for the design and graphical representation, we are using the ER model. But this relational databases are used to hold the actual data. Sandeep, you are too early for the lecture. So let us see what is the structure of relational databases. So relational databases consist of tables, each of which is assigned a unique name. For example, let us forget about the database. If consider we are creating any folder on our computer, within that we cannot have two files with the same name. Similarly, in case of database also, we cannot have two tables with the same name. Each table must be having a unique name, and of course we are going to follow the nomenclature that it should not be any keyword just like select, etc. Many more keywords are there, and it should not be any int, char, etc. because these are the data types. And similarly, whatever the name nomenclature we follow for the variables in the programming languages, just like it should start with the alphabet, and it should not have in between space. Yes, we can add numerics, but after the alphabetic characters only. So the same nomenclature we follow for the giving name to the tables. Each table will have a unique name, and within each table, whatever columns are there, table contains columns and rows. So within that columns, each this columns is also called as a fields or attributes. Each column will have its own unique name. Yes, if there are two tables, they can have the same column name within separate tables. But if we are taking the case of single table, it will have only unique column name. Again, the same nomenclature, start with the alphabet, should not use the keywords, and in between space should not be there, etc. So here, the first point says that a relational database consists of collection of tables, each of which is assigned a unique name. So am I running too fast? Am I clearly audible to all? Whether slides are clearly visible to you?
Yes, ma'am.
Okay, thank you. Okay, the next point says that in general, a row in a table represents a relationship among the set of values. So, okay, let us see what is meaning of this statement. Here, let us take an example. Okay, here I will draw a table. Okay, consider here I am writing 1. And then here I'm writing 2, and let us take here I'm writing 3. Okay, if I'm writing 1 2 3, I know that this is some kinds of number, and there might be some numbering given to any of the values, etc. So this 1 2 3 might be anything. And with this 1 2 3, if consider, if I'm giving the label to this as, this is a roll number. Okay, if I'm saying that these are the roll numbers, then it means that I'm turning some data into some information. That 1 2 3 is nothing but a roll number. And later on, if I'm saying that roll number AB, roll number 1 is having name ABC, roll number 2 is having some another name, and roll number 3 is also having some another name. In that case, I'm saying that this is a information related with each other. It means roll number 1 is having name ABC. So here a relation, it means that I'm connecting roll number and name together into a single table. And then I'm saying that roll number 1 is having ABC. It means this ABC value is independent. But if I'm trying to relate this ABC with roll number 1, it means that I'm establishing connection or relation between 1 and ABC. Then I can say that roll number 1 is having the name ABC. And that's why whatever these tables in the database systems are there, these are called as a relations. Relations, because here these are holding a related data together. Consider another case. Along with this name, here, if I'm having one more column here, okay, if I'm adding one more column here as marks, consider, and here I'm saying 70. If I'm saying 70 here, if I'm saying 71, it means that if I'm simply saying 70, 71, 72, this value doesn't carry any information, or doesn't give me any valid information, or doesn't make any valid conclusions. But if along with the table, along with the roll number and name, if I'm storing this value, it means that this 70, these are the marks of roll number 1 who is having name ABC. It means here this is a single row which is holding a related data. This is a row which is holding a related data. If consider roll number 1 is having some another name PQR, and I am writing here ABC, this doesn't carry any information. Here I am holding only related data with each other, and that's why rows are always holding a related data together. 70, these are the only marks available to roll number 1, and 71, these are the marks of roll number 2 only. And roll number 2 is having CVB as a name. So this is the way we are storing the information into a databases. Clear with this? So the second point says that in general, a row in table represents a relationship among a set of values. Set of values, I'm having marks as separate, I'm having name as separate, roll number as separate, and whatever this set of values are there, these are holded as a single record. Single record. So in mathematical terminology, a tuple is simply a sequence or list of values. So here, right now, we are having three columns. We might be having five columns. I am storing marks. I'm storing address of the student. I'm holding parent's name. I'm holding again another phone number, etc. It means whatever those many columns will be there, those many sequence of values will be there for each record or each row. So this is explained by the second point. That is, in mathematical terminology, a tuple, that is a row. It's simply a sequence or list of the values. So this can be a list of values. Right now, three columns we have taken. There might be multiple columns. A relationship between n values is represented mathematically by an n tuple of values. So whatever those many columns will be there, those many tuple values will be there. Right now we are having three columns. It means three tuple values are there. A tuple with n values which corresponds to a row in a table. So here every row in a table is called as a tuple. So this is given by using an example. Here this is a example. Here every column is a separate attribute, and every record or every row within my table is a separate record or tuple. So right now there are four columns. It means this is a four tuple value. Each record is holding a related information or relationship information. That ID 10101, this is a ID. For this ID is given to Srinivasan, who belongs to computer science and with salary as a 65,000. So this is how this relation or this table is holding a information. In relation model, the term relation is used to refer to a table. So every table will be called as a relation, while the term tuple is used to refer to a row. So every record or every row is called as a tuple. And similarly, the term attribute refers to a column of a table. So the same thing we are repeating. Next, the term relation instance to refer to a specific instance of a relation containing a set of values. So here instance, it means that instance means a set of values at particular moment. Consider here I am having a table with these many values. Consider here this student is having mark 78. Now today I know the result of three students. That's why there are three records. But as the time changes, the result of another students might be get displayed. So here I may say that roll number 4, who is having name anything, and is also having marks 77. So this is, it means the previously at yesterday's time I was having only three tuples, and today's time I'm having four tuples. So this is the way instance. It means that the set of values at particular moment of time. So the time, this might be just now second, or it might be after an hour, any unit of time we can take. So the data changes. So instance, it means that the set of values at particular instance or particular set of rows at that in that relation. So the term relation instance to refer to a specific instance of a relation. Instance, the existing current status of a relation containing a specific set of rows. So here we are having these many rows. Tomorrow again one more record might be get added, and that's why a separate instance will be there. So two instances, it means a database values at two different times will be there. So any doubt in this? Okay, so let us move to the next point. So this is an example of a simple relation where columns and rows are there. Next, let us see what is attribute types. Already in the ER diagrams, we have studied this point. So now we are learning this point with respect to the relational model. So attribute types, the first point says that the set of allowed values for each attribute is called as the domain of the attribute. So the domain of the attribute. So in this example, if I'm giving ID as of data type as integer, So it means domain of my ID will be integer, and there is only few set of the values which are allowed for ID. In the ID, I cannot enter ABCD, etc. because here this is not coming under the domain of integers. So it means domain, it means set of values permitted for the ID. If in the ID I'm giving the size as 11, so it means up to the 11 digit I can give any value. But if the size changes, again the set of values or range of the values allowed will be again changing. Attribute values are normally required to be atomic. Yes, atomic, indivisible. So here, if I'm having ID within the ID, if I'm saying that ID containing first part as a department code, second part contains as some another value, in that case, we don't say that ID is a atomic value. Atomic value which cannot be divided further. Just like here, department name is there. Department name, if I'm having as computer science, I cannot divide computer science, computer as a separate department and science as a separate department. No, here this is a name which I cannot divide further. So this, it means this is having atomic in nature. So here name is also attribute. In case of our name, it means the Indian nomenclature. Name contains three parts. But here, if we choose to only store either first name or second name, first name or last name, then that becomes a atomic in nature. So here only last name is a part of this database. Srinivasan, Mozart, you, Einstein, these are the only last name of the people which might be used for the official reason, and that's why only name is also atomic in nature in this case. We cannot say first name, middle name and last name as a part of name, and that's why again name is atomic in this table. Next, a special value null is a member of every domain, indicated that value is unknown. So here, consider that here recently a faculty has joined, and yet the scale is not decided. We know that faculty has joined this computer science department. So we make ID is always a given, as this is a unique and always given to every faculty. That's why ID also we can assign, name also we can assign, to which the particular instructor is assigned, that also we can assign, but salary is not yet decided. In that case, we may not want to lose the information that faculty ABC has joined, and yet because of salary only one field or two fields we are not willing, we are not able to insert the data. Here for this purpose we always having a option called as a null values. So null value, it means that the value which is unknown or doesn't exist. Yes, salary will always existing, and that's why right now the value is unknown. In that case we can assign the null value here. So null value refers to an unknown value, or consider here along with the instructor, along with this information, if we are storing the passport number also. So passport number, it might happen that because of a flexibility that you may have password, you may not have the password. In that case, if I don't have the password and still my record I wanted to enter into a relation, then in that case we can assign null value to the passport number, because null value says that the value passport number for me, for those the passport is not yet withdrawn, in that case we can assign the null value saying that that value doesn't exist. Okay, so if value doesn't exist or unknown, in that case we can go for saving the value null. But here whatever the primary key is there, primary key is always doesn't allow null value and neither allows the repeated value. And second attribute, name. So it may not happen that any person doesn't have name. Name is always a compulsory part of the information, and that's why we cannot assign, we can put the constraint that name should not be null. So such constraints can be also given onto the relation. So name, those which values are mandatory, that doesn't accept any null value, but those values which are not mandatory, they can accept the null value. The null value causes compilation in definition of many operation complications in The definition of mini operations, yes. Here, while studying SQL language, we might encounter this statement that because of null value, there can be problem. So, any doubt in this point? Structure of relational databases and attribute types. Okay, so let us go for the next point.
Ma'am, ma'am,
Yes. Hmm?
um,
Hmm,
uh,
yes, you are audible.
yeah, atomic
Hmm.
means please move the slide backward slide.
Okay. Hmm.
Uh, Attribute value are required to be atomic.
Hmm.
Can you explain once again this statement? I didn't understood.
Atomic in nature, it means that here, okay, okay, I will take an example of the last slide. Consider here name I have given as ABC. Okay, I will take my example. If in the name I'm giving this as a Sanjuni, Sachin, Kadam. Okay, this information I'm giving. So can you know that whether what is my first name, what is my last name, etc. Here in that case, it is easy for us to identify that yes, Sanjuni is the first name and Kadam is the last name. But there might be cases where we don't unable to understand that whether what is the first name and what might be the last name. In that case, if consider that this as a Sanjuni Sachin Kadam, only this example I have taken, and while entering your name, okay, consider I'm giving only simply that Fiza Sheikh. Okay, this is the only name I'm passing. Okay, while entering the name, I'm not keeping the restriction that you should enter in this format only or we should enter in this format only. Any person might enter this name, or instead of this you might give the name as Sheikh Fiza. Okay, so can you able to identify or put the restriction that which is one is first name and which one is last name?
No, ma'am.
No, because here human understanding is required, and human understanding through programming we cannot guess, and that's why here for separating this, yes, Sheikh is only last name and Fiza is my first name. In that case, we will be going for storing this value as atomic in nature. Here I can divide this Sanjuni as a first part, Sachin as second part, and Kadam as a third part. It means that here whatever this complete name is there, we need to divide this into, or this name can be divided into three subparts. In that case, atomic in nature, here this name element contain three subparts: first name, middle name, and last name. And that's why such types of name may cause any problem in accessing the database. And that's why here, or may not give the accurate results, etc. So we always go for the atomic values. Atomic values, whatever name is there, we should go for storing this as a separate parts. So here I will add columns. So here I will make this as a first name. Here I will store this as a middle name. And at the last part, I will use this as a last name. Then here, I will choose this Sanjuni as here. Then Sachin as here. Then, do you have any confusion now? What is my first name, what is my middle name, and what is last name? And if consider right now, I don't know whether what is middle name, etc. If I'm the clerk is filling the data, he might enter that this is the name. Yes, first name is Fiza and last name is Sheikh. Middle name right now don't know. That's why we might enter this as a null value here while entering the data. So this can happen. So anyone, it means here I cannot divide Sanjuni into further subparts. That doesn't carry any meaning. Okay. Okay, clear with this? Or still I should go for some another example?
No, ma'am. I got it. It is clear.
Sure?
Yeah, ma'am. Sure,
Okay.
you can proceed.
Okay. Still I will take some another example. Okay, right now, whatever numbers, it means phone numbers we are allowing. So if I'm simply saying that phone number, you will add some random mobile number, etc. But if consider any student doesn't have mobile number and that student is adding any landline number, okay, then he might enter that any pin code, that is sorry, any, sorry, any STD code, and later on some number, etc. Okay, so this is the number of the user. So now here, this phone number can be divided into subparts. Whether this phone number is atomic in nature. Hmm?
No, ma'am.
No, here because whatever this number is containing, this number contains two subparts. This is my STD code and this is my phone number. This phone number I cannot divide further because there is no any division among this. But here a STD code can be separated from the given number. Then it I can say that this is atomic in nature. Or right now, if I'm saying that this is my phone number, okay, okay, along with that this number I cannot divide further, but along with that if I'm saying that plus 91, so this is my country code. Okay, country code will be separated again, and here we will take a phone number. If simply phone number I'm saying, I will enter this code, but if consider my college allows for some international students also outside the country, in that case we may be willing to store phone number, etc., of those students also. In that case, here whatever default country code is there, that cannot be applied to those students. That's why we might be willing to store the country code as separate and phone number as a separate. So this is how we are maintaining the atomic data. Atomic data, the data which cannot be divided further. Previously, this complete phone number was together, but this phone number consisting two information. First, yesterday code, and second one, the actual phone number. That's why we divided this phone number. But now, if we divide this yesterday code and phone number as separate, there is no further any subpart or subdivision is possible within this code also. Within this number I cannot make that this 97 refers to the Airtel, this 66 refers to the Pandharpur, etc. There is no any nomenclature. Simply phone number is there which cannot be divided further, and this complete part is required to give the information. Yes, along with that, if I'm giving plus 91, it means that I'm saying that this phone number belongs to the India. So this is how we are storing the atomic information which cannot be divided further. We can take the example of address, or we can take example of any locality, etc. So where the information can be divided into subparts. So here we have taken example of the name as well as a phone number also. Okay, now it is clear. Okay, let us go for the next topic. Next point, database schema. So what is mean by schema? Anyone?
Structure of the database,
Yes, structure of the database.
or
And
how we
what?
can.
Yes,
Okay.
what is the design of or what is which information we are going to store? That is given by a schema. So database schema, it means a logical design of the database, and the database instance is, it means snapshot. It means whatever current information is there, the same. It means the information available into my database at particular moment of time. Then I can say that that is a database instance. Instance, the value of database, the records of my database, or the set of values within my database. So that is a database instance. Database instance is a snapshot of the data in the database at given instant in time. So here, a database consists of multiple relations. So the schema of all the relations will be called as a database schema. So each relation will have its own structure, that how many columns are there, what is the data type, which one is the primary key, whether foreign key is there, etc. Whatever the schema part is there, that will be a relational schema. And whatever the relations, all the relations are available into a database, that will be called as a relational schema. So the second point says that the concept of a relation corresponds to the programming language notion of a variable. So here, if consider, we are saying that here, let us read the second point first. The concept of a relation corresponds to a programming language notion of a variable, while the concept of relation schema corresponds to the programming language notion of a type definition. Okay, so let us see what is meaning by this. Here, if I'm saying that int a is there, okay, in programming languages, any language we can take. So here, schema, it means that a's data type is integer. It means here I can say that which operations I can perform on a, and which is a set of values allowed for the a. Okay, that is the meaning. But when we say that right now a equal to 10 is there, a equal to 10 right now is there, and later on I perform some operations, and because of which a's value become 20, then it means that this a equal to 10 is the instance of a at some another time, and after some time this will be the instance of a. If I'm saying int a, this will be called as a schema definition or schema in terms of database. So relation schema corresponds to the programming language notion of type definition. That if I'm defining that a is of type integer, it means that I'm defining that what kinds of data a can hold. Similarly, the same notion we apply for the relation schema. For example, if I'm saying that, so if I'm saying that instructor instructor, within that, if I'm saying that it is storing id, it is storing name, it is storing department name, and it is also storing salary. Okay, these are the parts. It means that here I'm deciding that within my instructor table, id is one column, name is another column, department name is another column, and salary. So it means whatever the record of instructor is there, this will have these many values, or these many tuples, or these many columns will be there. That is defined. So that's why this will be called as a schema of a relation. So here, same point is continued. Whether this is visible, or should I make it bold? So here, so A1, A2, AN are attributes. So R equal to, in bracket, A1, A2, and AN is a relation schema. So example, just now I given instructor contains ID, name, department name, and salary. So this is the schema of the instructor. So let us take D1, D2, Dn. These are the domains of these attributes. So it means formally a given set D1, D2, Dn. A relation R is subset of D1 multiplied by D2, not multiplied by, that is cross. It means this sign in terms of database is used for the uh, giving a single tuple value D1, D2, and Dn. So this relation is a set of n tuples that A1, A2 up to An, where Ai belongs to Di. So it means here D1, if I'm saying that ID of type int is there. So ID of type int is there. Name of type, let us take character first. Character is there. Okay. Next, department name, again character is there. And salary, let us consider int or float is there. Okay, so this is how it means every tuple, this will be a my tuple value with all these domains, and every AI, it means here if A1 is there, A1 will be belong to first, that is D1, A2 will be belonging to D2, and AN will be belonging to DN. So this is how these each tuple the value is given. So I cannot have this float as first and int at the last. No, whatever the given structure is there, within the same structure, we should pass the value. So if I'm inserting record into an instructor, this record will be always in the format first integer value, next character, and then float value. If any other combination is there, we should explicitly need to specify that we are changing the flow. Okay, this is the relational schema. The current values or whatever the existing value set is there, values relation instance of a relation are specified by a table. So whatever the table right now we have seen for the instructor, that is a relation instance. An element T of R is a tuple, that every record is a tuple represented by a row in a table. So the same things we are learning repeatedly, because here we need to first understand what is mean by a row, what is mean by tuple, what is mean by column, what is mean by attributes here. So instance and schema. So these are the frequent words which we will be using always during the relational model. So next, relations are unordered. So here there is no any specific rule that if I'm inserting first two records, then I'm inserting second two in the same sequence, it should display, etc. So there is no any order specified for the tuples. So order of tuple is irrelevant. Tuples may be sorted in arbitrary order. It means we can have any order of the elements. So the same table, whatever instructor table we have seen in the first slide, first figure, the same figure is there. Example, instruction relation with unordered tuples. So here, this record always, just like these records are treated as a set elements. Set element, if consider, I'm saying that a equal to in curly bracket 1 comma 2 comma 3. Okay, this is my set. So in the same set, if I'm saying that a equal to 3 comma 2 comma 1 or 1, the same first a and second a both are same, because here whatever repeated records are there, these will be treated as a single record, because repetition of the elements is not allowed in the set, and that's why even though I'm inserting the same record repeatedly, this won't accept the repeated record, and only single copy of that record will be there. And order of the element also doesn't matter in case of this relation set. So relations, these are holding the records or rows are always treated as a set element. Yes, we can control the display of those elements. We can sort them based on the ID. We can sort based on the name. or we can display department wise, etc. Any whatever display is there, we can go for. But whatever the default display is there, that default display may be any random display of the element. So there is no fixed order here. Whatever tuples are there, these are always unordered tuples are there. Clear
Hello,
with
ma'am.
this? Yes.
Ma'am, means you had given, you have taken the one practical in previous lecture, okay?
Hmm.
And
Hmm.
you had specified that if we have to store the data like unorder, like means insert. If we fire the
Hmm. Hmm.
inserting query, then you have to specify
Hmm.
syntax in bracket. Like we are first of all we are like uh, suppose we are considering ID name, department name, and salary. If we store name,
Hmm.
department name, then salary, then ID, then um,
Hmm.
you have taught that like we have to specify the syntax over there.
Hmm. 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 Hmm.
Means this term is related to that only.
No, 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 no. Here I'm saying that here, whatever the structure is there, ID name, department name. Okay, so I will take an example of a insert query here. If consider I'm storing insert, okay, insert into table name is instructor, okay, instructor. And if consider I'm in here I will use the values, okay, values. So here whatever the default order is there, default order says that first type is domain, first domain is integer, next is character, next is character, and last one is the float. Here I cannot change the flow that here I will use a b c d etc, because here that is not allowed here, because the first column of this table by default, here I'm not inserting any column list etc, it means it will take a default order of my column. So default order of the column, first column is an integer value, and that's why whatever if I'm trying to execute this query, that first column should be uh, name, then if I'm giving the second time as computer science etc, okay, and next I'm choosing let us take next I'm choosing uh, salary, and then if I'm choosing the ID, so in that case, by default order, what it will do, it will try to check whatever this ASBC is there, this will try to add this value into ID, which is of type integer. In that case, this query will not be executed. This will say that the domain values are not matching or incorrect value is inserted, and that's why here this will not accept this value there. Yes. If a character is there, this will accept the numeric value, because numerics are also accepted in case of character values. But when it comes to inserting character values into the numeric, this will not accept, because ASBC I cannot convert into any equivalent value etc. That's why here, whatever the domain of my ID is there, which is of type integer, then at the first domain here I should insert only a value of integer only. Yes. If I'm saying that I should change the order, then I can here specify that first should be a name, second should be department name, third value refers to the salary, and fourth value refers to the ID. Then here, whatever this one-to-one mapping is there, that will be correct. That first is name, map with the name. Second is department name, map with the department name. Yes, both are character, acceptable. Then third is salary. Yes, float is also acceptable, and ID is integer. Then it is acceptable. If without explicitly mention, if we're trying to change the domain, this will not accept. Am I answered your question?
Yeah, ma'am.
Sure.
Yeah, yes.
Okay. Whereas if we are using the tables into a file system, okay, consider that in the Word document we have created any table, and there we are trying to insert this data. In that case, this will accept this data without checking whether this value is ID, value is valid or not. In that case, that is also drawback of a file system, that it doesn't check the consistency of the database. If I'm giving in the table columns, we cannot put some restrictions. Okay, for example, here we have created a table. Here in normal file processing, I can enter any data here, but roll number should be always numeric. That restriction we cannot assign into the file system. File system doesn't allow me to restrict this data. Again, if I'm trying to insert one roll number, two roll number, this repeatedly, still it won't for it means restrict me that you should not enter this data. And even if I'm having only 100 students with me, and here I'm giving the roll number as 500, still this will accept the data without putting any of the restrictions. And that's why here integrity problem, whatever we say, that is the same problem, that it doesn't check for the correctness of the or consistency of the data values. And if in the name here I'm giving 1 2 3 4 etc., still that will accept the values. So now comes the main point. So here, before starting with this point, I want you to read this point and revise those things which we have studied in case of a foreign key. ER model, whatever we have learned. Please, for a minute, read this slide, and we will start with the explanation regarding the keys. Read the slide. So here during ER model, we have seen three keys. So key, this refers to a set, a single attribute or set of the attributes which are used to identify any entity uniquely. For this purpose, we are using the keys. So remember that during placement drives, etc. So first question always asked on the database is always based on the key. So key, from which point your understanding starts reflecting during the interviews. So keys, these are the most important part of the always database interviews. So key, this is a set of attributes which are used to uniquely identify an entity. Right now we are talking about the ER model. Entity from a set of entities. So here, this might be one attribute or this might be number of attributes. So here, if we take a super key, any attribute or any superset of the attributes can be acting as a super key. So let us see the same meaning we are giving with respect to the relational model. So let us see each of the statement one by one. So first says let K be a subset of R. So R, it means that here the complete set of the attributes. So right now in the instructor, we are having the attributes ID, name, department name, and salary. So these four attributes forms my R, and any combination of the attributes id, name, department name, or salary, or any subset id, name, id, department name, id, salary, or name, department name, salary, any combination of these attributes. So k refers to a subset of R. So k is a super key of R. It means k, a subset of super key, a subset of attributes, is a super key of R if values of key are sufficient to identify a unique tuple of each possible relation R of R. So here example is given. So ID is not repeated here. It means that ID is sufficient to uniquely identify any of the instructor. Again, if we are taking ID and name, this both combinedly also can form a super key. So super key, it means that whatever the current attribute plus any superset. Superset are both super keys of the instructor. Again, ID name, ID department name can be there, or ID salary is also there. This both also can identify any instructor uniquely. So super key. So within that, again, candidate key is a minimal super key. So the second definition says that super key K is a candidate key if K is minimal. Minimal, here ID, we cannot divide this, and ID and name. If we separate this ID and name, ID is sufficient to give the unique record, but name is insufficient. In that case, I can say that ID is a minimal super key. So here, example, ID is a candidate key for the instructor. Yes, one of the candidate key is selected to be a primary key. So there can be multiple candidate keys can be there to each relation, and out of that one is chosen as a primary key. So here the question comes, which one to be chosen as a primary key? Okay, let us go back to the relation. Okay, so in the relation, we are having name and department name and salary. So the question comes, can we choose salary as a candidate key? Here we can see that there is a repeated value for the repeated values are there, and value can be anything. Two instructors might be having the same scale, and that's why salary also we cannot choose as a primary key. Next, department name. So here I can see the physics value, it means only department name also we cannot choose. But if we choose here, so here minimal super key we wanted to get. So if simply ID I am choosing, then this can be a candidate key. If we say that there is only single faculty with same name in the each of the department name, name and department name. This can be my candidate key, that in every department there is only single faculty with same name. Yes, there are names are repeated, but in the each department there is only single faculty with that name. Then we can say that name and department name also can become my candidate key. If I simply divide this into name and department name, name is also insufficient to give the unique record, and department name is also insufficient to give me the unique record. Then I can say that this is a minimal super key which cannot be divided further and cannot give me the unique record. And then along with that, if I am choosing name and salary, name and salary can be there or may not be there. Let us take right now, this is not giving me the unique record. In that case, which one is easy to handle, whether id simply is easy to handle or name and department name, this both are easy to handle as a primary key. Any idea which one to be chosen as a primary key?
Ma'am, ID is chosen to be primary key because it is easy to handle. Because
Yes.
everyone have the unique ID.
Yes, yeah, everyone is having a unique ID, and there are two attributes are there in the second key, that name and department name. So, which is called as a composite primary key. If consider we say that that is a primary key. So, in that case, this might be yes, name will not change because person's name may not change, and department name. Today, I am assigned to the computer department. If consider because of some reason, management decide that I should be the part of some R&D work, and because of which they changed my department name. It means there are chances of the department name to be get changed. So in that case, while choosing the primary key, always the care is taken that the key or primary key value should rarely change or doesn't change. So that is that care taken during the choosing the primary key. And the next matter, id is a integer value and name is a character value. So always whenever we are performing the operation, integer values are always easy to handle as compared to the alphabetical value, and that's why id will be chosen as a primary key, because here referring to any faculty from one table to another, right now we are having this much information. If considered because of some reason few faculties are assigned with some another task, and I wanted to store this information in some another relation, then name and department, storing these two columns and repeating the same information there. Instead of that, simply take the id of Einstein and save their information. It means whenever I'm referring id, this is referring to Einstein from physics department and with salary xyz. So it means it is easy to refer to a single column instead of over two columns, and also easy to refer to integer value over the alphabetical value. So primary key is always chosen in the same way, that it shouldn't change, it must not change or rarely change, easy to handle with the operations, and that's why instead of using the composite key, always we go for the single attribute key. Okay, if there are no attributes, then we can it means we must go for the composite attribute, but if there is a choice for the single attribute, then always primary key is chosen as a single attribute only. And here, if consider here right now this instructor table is there. Just now I taken the example that if from this table few faculties have assigned with some additional tasks, and there I wanted to store information that whatever this id instructor is there, this is working on some another project. Okay, and project name, this information I wanted to store, and there might be some mentor along with our team. So mentor, this information we wanted to store. So now within that, this is another relation. Okay, this is another relation, or I can assign this name as a inst table or project. Okay, this is my table name. We cannot use dash in the table name. We should always use a uh, this underscore. So instructor project, this is another relation which is maintaining information that which instructor is allocated to which project and who is the mentor. Okay. Now here this is the combination of IDs. Consider that these are the only instructors available. So now do you think that I should enter here a value 5 times or 3 times 5? Okay, 5 times 5, and project name is student rating app or a rating app. Okay, this is the project allocated, and mentor it's Marathe sir. Okay, now do you think that this data is valid? I will reduce the size of this relation. So now do you think that this data is valid? Data valid, I mean whatever this record 5 times 5, this ID is correct. Whether there is any instructor who is having this ID right now, whatever this information is there, this is the same information about the relations is there, and I am trying to insert that this ID, faculty with this ID has been allocated to this project under Marathi sir. So now do you think that this data is valid data?
Ma'am,
Yes.
uh, this is not valid data because such kind of means which ID you have given, that
Huh,
kind of
yes.
mentor is not present in our database, and ID is also not present.
Okay, referring to mentor, we might be. It means right now mentor is not part of our this table. That's why mentor also I can skip. But here, whatever ID is there, ID should be correct. ID should be among those values which are the existing values in my instructor table. Here, I will switch to Marathi. जे काय इन्स्ट्रक्टर माझ्या टेबलमध्ये आहेत, म्हणजे जे काय इन्स्ट्रक्टर माझ्या कॉलेजमध्ये आहेत, त्यांची सगळी इन्फॉर्मेशन ह्या इन्स्ट्रक्टर टेबलमध्ये आहे. आणि इथले जे फॅकल्टी आहेत तेच फॅकल्टी, म्हणजे त्यांपैकीच काही फॅकल्टी मी या प्रोजेक्टसाठी असाइन केलं. मग त्या केसमध्ये जो काय मी आयडी इथे टाकते, तो आयडी ऑलरेडी या टेबलमध्ये एक्झिस्टिंग हवा. दॅट इज द कन्स्टेंट हिअर. म्हणजे मी असं नाही करू शकत माझी क्लास स्ट्रेंथ 80 पर्यंत आहे आणि मी एखादा रोल नंबर 81 ला माझे नोट्स दिलेत असं जर सांगितलं तर कोणी विश्वास ठेवेल का? नो. हिअर वॉट एव्हर द रोल नंबर आय एम सेइंग दॅट शुड बी अमंग द एक्झिस्टिंग व्हॅल्यूज. सो हिअर रोल नंबर इज नॉट अ रिपीटेड व्हॅल्यू. ओके, रोल नंबर ही व्हॅल्यू काय रिपीट होत नाहीये. दॅट्स वाय आय गिविंग द ॲज अ primary key. In that case, if I'm saying that this value is already existing somewhere, and for ID to be a valid data, I am taking reference of this ID column, then this is called as a foreign key in the another table. Okay, here I'm having the table as inst project. Inst project contains information about those instructors who have been assigned with some project. Okay, here whatever this ID is there, this is the ID of the instructor who has been assigned with this project, but that ID is unavailable here. That cannot be a condition in the real life situation. Real life situation जे काय माझ्या इथे इन्स्ट्रक्टर आहेत त्यांच्यापैकीच कुणाला तरी हा प्रोजेक्ट दिलेला असणार आहे, आणि ती व्हॅल्यू जर माझ्या मेन टेबलमध्ये जर नसेल, देन आय कॅन से दॅट ही व्हॅल्यू इनकरेक्ट आहे. आणि या टेबल मधल्या कनेक्शनचा हाच एक पॉइंट आहे. देन इट मे रेफर टू द फॉल्स डेटा और इनव्हॅलिड डेटा. For this purpose, we must give the restriction on this ID that ID value should always exist among these values. This constraint is called as a foreign key. Foreign key, it means that primary key of some another table or candidate key of some table is being referred to some another table. Here, whatever this inst project is there, inst project always should have ID value which is already there in the instructor relation. So next is the same point. Foreign key constraint. Foreign key constraint says that value in one relation must appear in some another relation. Okay. So in that case, from where we are referring to the value, that is a referencing relation, and the table from which we have taken the value, that is called as a reference relation. Example here, they have taken the department name in instructor is a foreign key from the instructor referencing relation. So let us see what is mean by this part. So here I am having the department name as physics, finance, history, etc. Let us take an example of our college. And in the instructor, if consider I am storing the instructor tuple value, ID I have assigned as 1, 2, 3, 4, 5. Okay, this is the ID of the instructor. Name of the instructor is AAA, and uh, instructor has been assigned to the department production. Okay, production department with salary as consider 89,000. Okay, this tuple I have inserted. Consider we are maintaining the database for our college. In college, we are having only 5 departments: computer science and engineering, mechanical engineering, electrical and electronics and telecommunication, and last one is civil. So now do you think that if I'm assigning the department name as a production, will this be a valid data? Will this be a valid data?
No,
असं असू
ma'am.
शकतो.
No.
येस, नो, दॅट इज द सेम पॉइंट. म्हणजे मी जर डिपार्टमेंट नेम जर इथं कुठलं रेफर करत असेल तर ते माझ्या डिपार्टमेंटच्या रिलेशन मध्ये यायला हवं, ते एक्झिस्टिंग असायला हवं. व्हॉट एव्हर द डिपार्टमेंट रिलेशन आय एम मेंटेनिंग, डिपार्टमेंट जे काय रिलेशन मी मेंटेन करते त्याच्यामध्ये सगळ्या डिपार्टमेंटची एंट्री असणार आहे, आणि त्या डिपार्टमेंटमध्ये जर प्रोडक्शनचं डिपार्टमेंट असेल तरच ती व्हॅल्यू मी इथे लिहू शकते. Else this entry should not be allowed. In that case, here department name will be called as a foreign key in the instructor table. In that case, what your department relation is there? In that case, what your department, this relation is there, this will be called as a reference relation, and instructor which is using or which is referring to that table will be called as a referencing relation. Referencing relation. So this is the difference between keys. Department, in the department, whatever department name, primary key is there, that is being referred into the instructor. म्हणजे इन्स्ट्रक्टर मध्ये प्रत्येक वेळेस ज्या ज्या वेळेस मी डिपार्टमेंट नेमची व्हॅल्यू एंटर करते त्या त्यावेळेस ते चेक करणार की ही व्हॅल्यू ह्या डिपार्टमेंट टेबल मध्ये आहे का. असेल तर ठीक, नाहीतर मग ती एंट्री माझ्या इन्स्ट्रक्टर मध्ये इनव्हॅलिड मानली जाईल आणि ती इनव्हॅलिड एंट्री इन्स्ट्रक्टर रिलेशन ऍक्सेप्ट करणार नाही. सो याची primary key I'm using over here. In that case, this department will be called as a reference relation and instructor will be called as a referencing relation. So here म्हणजे मग whether तिथं प्रायमरी की असली म्हणून माझ्या इन्स्ट्रक्टर मध्ये पण ते प्रायमरी की असते का? No. Here, whenever we are putting the foreign key constraint, foreign key can take repeated values and this can take the null values also. इट मीन्स समजा एखाद्या इन्स्ट्रक्टरचा डिपार्टमेंट नेम आपल्याला माहितीच नाहीये. इन दॅट केस वी मे असाइन द नल व्हॅल्यू अँड लेटर ऑन ऑल्सो वी कॅन ऍड दिस व्हॅल्यू. अँड as we can see, there are multiple faculties allocated to the department name. It means this can have the repeated value also. Only that constraint, that this is a primary key constraint, will be applicable to department and that constraint will not be available to the instructor. Clear with this foreign key? Foreign key, among all the keys, most of the questions will be based on the foreign key. So here the referencing relation says that, so foreign key constraint, value in one relation must appear in some another relation. Referencing relation, which is referring to some another value, and reference relation, it means that from which table we are taking the value. Then example here, department name in instructor is a foreign key from instructor referencing department relation. Clear with this?
Ma'am,
Yes, yes.
referencing relation and refers
Hmm.
reference relation should be from one table, or it is valid, we can take it from two table also.
Yes, we can take from two tables also. That is, if we are referring to single column, okay? Here, let us take this one. Department name is a single column. It means this can be a foreign key from only one table only. म्हणजे असं नाही, हा सॅलरी मध्ये समजा माझी स्केल काय आहे की सॅलरी मध्ये एक सिलेक्टेड सेट ऑफ व्हॅल्यूज आहेत, त्या जर तुम्ही रेफर करत असाल तर मग तो माझा प्रायमरी की दुसऱ्या टेबल मधून असू शकतो. म्हणजे इथं मी डिपार्टमेंट नेम घेतलेला आहे, डिपार्टमेंट नेम मधून ही रेफर केली. हा कॉलम दुसऱ्या कुठल्या तरी टेबल मधला असू शकतो, हा कॉलम तिसऱ्या कुठल्या तरी टेबल मधला असो, तर कुठलाही असू शकतो. मग त्या केसमध्ये माझ्या 2-3 फॉरेन कीज इथे झाल्या. हा, पण डिपार्टमेंट नेम ही फक्त तुम्ही एकाच टेबल मधून घेऊ शकता. डिपार्टमेंट नेम 4 टेबल मधून तुम्ही एका टेबलमध्ये ऍज अ फॉरेन की म्हणून घेऊ शकत नाही. ती कुठल्या तरी एकाच टेबलच्या व्हॅल्यूला रेफर करते. क्लिअर आहे का? मी अजून एक एक्झाम्पल घेते. हिअर स्कीमा डायग्राम ऍक्च्युअली नेक्स्ट पार्ट आहे.
मॅम
फिगर
काय म्हणतात नाही का ना, फॉरेन की आहे ना, मीन्स आपण इनव्हॅलिड डेटा एंटर केलं तर मीन्स ते एंटर नाही व्हायला पाहिजे. जेव्हा
हा
मीन्स
हा रेस्ट्रिक्ट करते. हो,
when I has read those point, means like what I understood like that, means मला काय कळलं की नाही का ना, जेव्हा पण मीन्स रेफरन्सिंग रिलेशन मीन्स व्हॉट, जिथून आपण डेटा घेतो, आणि रेफर रिलेशन मीन्स व्हॉट, मीन्स जिथं आपला डेटा आहे. आणि
नाही नाही नाही, तुम्ही उलट करताय. रेफरन्स्ड रेफरन्स्ड म्हणजे मी इथं रेफरन्स्ड डिपार्टमेंट ही माझे रेफरन्स रिलेशन झाले, आणि ज्याच्यामध्ये मी व्हॅल्यू यूज करते ती माझी रेफरन्सिंग रिलेशन झाले. ओके, दिस वन इज माय रेफरन्सिंग रिलेशन. म्हणजे जी कुठली हा टेबल अजून तो रेफर करतोय व्हॅल्यू ना, हा टेबल इन्स्ट्रक्टर टेबल डिपार्टमेंटसाठी, डिपार्टमेंट ही माझी रेफरन्स झाली. याच्यामध्ये मी रेफर्ड व्हॅल्यू, याच्यामधल्या व्हॅल्यूज मी याच्यामध्ये रेफर करते. कशामध्ये? इन्स्ट्रक्टर मध्ये. रेफरन्सिंग माझी इन्स्ट्रक्टर झाली आणि रेफरन्स म्हणजे माझे डिपार्टमेंट झाले. इथं पण मी तोच पॉइंट सांगितलाय की डिपार्टमेंट जे आहे ती माझी रेफरन्स रिलेशन झाली आणि इन्स्ट्रक्टर जे आहे ते रेफरन्सिंग रिलेशन झाले. क्लिअर आहे का कन्फ्युजन? मी डिपार्टमेंट नेम मध्ये व्हॅल्यू ऑलरेडी स्टोअर करून झालेले आहेत. डिपार्टमेंट मध्ये मी कुठलंही डिपार्टमेंट टाकू शकते. सध्या माझं सिव्हिल आहे, मेकॅनिकल आहे, कुठलंही डिपार्टमेंट टाकू शकते. उद्या माझं 6वं डिपार्टमेंट आलं, म्हणजे याचं समजा आयटी आलं, मग मी आयटी डिपार्टमेंट मध्ये मला तो रेस्ट्रिक्ट करत नाही की तुम्ही आयटी नाही टाकायचं, हे नाही टाकायचं, असं काही मला रेस्ट्रिक्ट करत नाही ते. पण इन्स्ट्रक्टर मध्ये मला ते रेस्ट्रिक्ट करू शकतं की बाबा आयटी डिपार्टमेंट त्या डिपार्टमेंट टेबल मध्ये नाहीये, देन यू कॅनॉट इन्सर्ट दॅट व्हॅल्यू.
मॅम
हा,
लास्ट क्वेश्चन.
no, you can ask many questions, no problem.
Actually, I'm little bit confused. I'm means which I have understood and which you have told by you.
Ha,
Like
ha.
that are totally different. So I'm confusing.
Which are totally different.
Means which I'm when you means when you were told to just read out those points, and when I have read
Ha.
those, and when you explain those points, that maybe means
Hmm.
it caused difficulties me to understand.
Okay, do you want me to foreign to repeat?
मॅम सपोज मी तुम्हाला 2 टेबल देते. ओके, आता काय
हा.
सांगू की नाही का ना, एका टेबल मागचा टेबल कन्सिडर करूया, हा दुसरा टेबल
हा,
आपण
हा.
दुसरा कन्सिडर करूया, आणि त्यामध्ये आपली
हा.
जी 5-5-5 वाली आयडिया आहे ना, ते त्यामध्ये प्रेझेंट आहे. इथं 1 2 3 4
हा.
5 नाहीये, आणि ते दुसऱ्या टेबल मध्ये आहे. तर मला हे सांगा की नाही का ना, रेफरन्सिंग आणि रेफर्ड काय असेल यात?
ओके, मी तुम्हाला सांगते. हे बघा, टेबल 1 म्हणजे माझा इन्स्ट्रक्टर. ओके, टेबल 1 झाला. आणि समजा दुसऱ्या टेबलमध्ये मी त्या इन्स्ट्रक्टरला काहीतरी प्रोजेक्ट असाइन केला म्हणून त्यांच्याबद्दल एक्स्ट्रा इन्फॉर्मेशन इथे स्टोअर करते. ओके, म्हणजे माझा मेन टेबल कुठला आहे? टेबल 1. दिस इज माय मेन टेबल. याच्यामध्ये माझी काहीतरी प्रायमरी की आहे. ओके, पीके दॅट इज माय प्रायमरी की. मग यातली प्रायमरी की जर मी टेबल 2 मध्ये जर रेफर करत असेल, म्हणजे याच्यामध्ये काहीतरी सेट ऑफ व्हॅल्यूज आहेत. समजा माझे 80 स्टुडंट आहेत, 80 स्टुडंटचे 1 to 80 रोल नंबर आहेत. मग त्या केसमध्ये मी कुणाला काय दिलंय, किंवा समजा माझ्या स्टुडंटने कुठल्या तर याच्यामध्ये पार्टिसिपेट केलं, मग त्या केसमध्ये टेबल 1 ची जी प्रायमरी की आहे ती मी टेबल 2 मध्ये करणार. मग ती माझ्या इथं फॉरेन की म्हणून युज होणार. मग फॉरेन की मध्ये काय होतं की ती फॉरेन की ज्या ज्या वेळेस व्हॅल्यू इन्सर्ट करायला बघते त्यावेळेस इट विल टेक अन एक्झाम रेफरन्स ऑफ दिस टेबल 1, अँड दॅट्स वाय दिस इज कॉल्ड ॲज अ रेफरन्स. इथं माझा रेफरन्स ही माझा टेबल झाला, म्हणजे ज्याची मी व्हॅल्यू इन्सर्ट साठी रेफरन्स म्हणून मी टेबल 1 यूज करणार. आणि टेबल 2 मध्ये दिस विल बी कॉल्ड ॲज अ रेफरन्सिंग रिलेशन. दिस विल बी अ रेफरन्सिंग रिलेशन. प्रायमरी की जिथं आहे दॅट इज माय रेफरन्स रिलेशन, अँड वॉट एव्हर टेबल 2, if this primary key I have been referring here, then fk जिथे जिथे माझं ही प्रायमरी की ॲज अ फॉरेन की म्हणून यूज केलेली आहे ती झाली माझी रेफरन्सिंग रिलेशन. आता समजा हा माझा स्टुडंट टेबल आहे, स्टुडंटचे आयडी रोल नंबर वगैरे सगळे आहेत, आणि समजा टेबल 2 आहे जिथे मी स्टुडंटचा एक्स्ट्रा करिक्युलर काहीतरी इन्फॉर्मेशन स्टोअर करते. हिअर आय एम ट्राइंग टू इन्सर्ट 85 ॲज अ रोल नंबर. This will not accept. This will accept, or this will check whether whatever roll number you are trying to insert is already available here. If so, allow the entry. If not, don't allow the entry. मग आता प्रायमरी की मध्ये माझं रेस्ट्रिक्शन काय आहे की माझं प्रायमरी की म्हणजे अनरिपीटेड आणि मॅन्डेटरी व्हॅल्यूज आहेत. हा, इथे मी रेस्ट्रिक्शन काय करू देते, 1 to 80 रोल नंबर आहे आणि दुसऱ्या कुठला 81 ची एंट्री टाकते, मी परत एखादा रोल नंबर 80च्या वरचाच युज करते, काहीतरी 75 किंवा 72 म्हणून तोच रोल नंबर जर रेफर करत असेल, दिस विल रेस्ट्रिक्ट मी. म्हणजे माझा प्रायमरी कीचा जो काय रेस्ट्रिक्शन आहे नॉन रिपीटेबल आणि मॅन्डेटरी ते माझ्या इथल्या कीला अप्लाय होणार. हा, मग तुम्ही 80 नंतर 81 जरी दिलं, 81 दिलं, 82 दिलं, किंवा मी ऑटो इन्क्रीमेंट केलं तिथं, मग ते ऍक्सेप्ट करेल. इथं कुठलीही व्हॅल्यूला ते ऍक्सेप्ट म्हणजे नाही करायला ते फोर्स नाही करणार. पण इथं रिपीटेड व्हॅल्यूज नाहीत चालणार. हा, पण इथं समजा माझ्या एका स्टुडंटनं 4 इव्हेंट मध्ये पार्टिसिपेट केलं, मग त्या केसमध्ये त्या कीची व्हॅल्यू इथे रिपीट होती ना. समजा रोल नंबर 7 आहे आणि त्या रोल नंबर 7 न 4 इव्हेंट मध्ये पार्टिसिपेट केले, मग ती व्हॅल्यू इथे रिपीट होऊ शकते. मग याचा अर्थ काय की ही जी रिलेशन आहे ही ऑलवेज रेफरिंग टू दिस रिलेशन, and this relation table 1 is being referred or referenced by table 2. ओके, तुम्ही हे एक्झॅक्टली उलट करताय. तुम्ही याला रेफरन्सिंग म्हणताय आणि इथं रेफरन्स म्हणताय. नाही, टेबल 2 व्हॅल्यू एंट्रीसाठी या टेबलवर डिपेंडेंट आहे, टेबल 1 वर. ओके, अँड दॅट्स वाय दिस इज कॉल्ड ॲज अ रेफरन्स रिलेशन अँड दिस इज कॉल्ड ॲज अ रेफरन्सिंग रिलेशन. टेबल 1 ना कुठलेही व्हॅल्यूज इन्सर्ट किंवा मॉडिफाय करू शकतो, त्याला रेस्ट्रिक्शन येत नाही. पण टेबल 2 मध्ये मी कुठलंही ऑपरेशन जर करायचं म्हणलं इन्सर्टचं, तर मला आधी टेबल 1 चा रेफरन्स घ्यावा लागतो. डिफिकल्ट जाते?
नाही,
हा,
नाव इट इज क्लिअर.
शुअर.
हा, या मीन्स
ऍक्च्युली फॉरेन की म्हणजे कसं की फॉरेन की म्हणजे प्रायमरी की एका टेबलची आहे, हो, पण स्टुडंट्स काय करतात की ती तिथं पण प्रायमरी की असली पाहिजे असं रेस्ट्रिक्शन लावतात. तसं नाहीये, प्रायमरी की फक्त या टेबलसाठी झाले. हा, मग प्रायमरी की इथे ठेवायची का नाही, मी असं रेस्ट्रिक्शन दिलं की प्रत्येक स्टुडंट फक्त एकाच इव्हेंट मध्ये पार्टिसिपेट केलं पाहिजे. तसं रेस्ट्रिक्शन मी देऊ पण शकते किंवा नाही देऊ शकते. मग त्या केसमध्ये माझी स्वतःची विषय आहे की मी द्यायचं का नाही. हा, मग ती जर समजा मी रेस्ट्रिक्शन दिलं, मग ती इथं पण प्रायमरी की होईल, पण ते मॅन्डेटरी नाहीये. फॉरेन की म्हणजे काय की तुम्ही फक्त व्हॅल्यू व्हॅलिड आहे का नाही ते चेक करता. मग त्याला म्हणायचं रेफरन्शियल इंटिग्रिटी कन्स्ट्रेंट. हे आपल्याला आहे अजून पुढे, पण एसक्यूएल मध्ये जास्त डिटेलमध्ये आहे. ओके, फक्त फॉरेन कीचा कन्सेप्ट तुम्हाला कळाला का?
हो मॅम, कळालं.
ओके, रेफरन्स आणि रेफरन्सिंग मध्ये आता डाऊट नाहीये?
नो मॅम, नो, आता काही नाहीये. Actually, I'm differentiating among super key, candidate key, and primary key. That's why it caused a confusion to me.
नाही नाही नाही. ज्यावेळेस तुम्ही कॅन्डिडेट कीला येता ना, सुपर कीचा कन्सेप्ट काढून टाकायचा. ज्यावेळेस तुम्ही
हा.
प्रायमरी कीला येता त्यावेळेस कॅन्डिडेट कीचा कन्सेप्ट मनातून काढून टाकायचा. आणि ज्यावेळेस तुम्ही फॉरेन कीला येता त्यावेळेस फक्त प्रायमरी की आणि फॉरेन की हे दोनच विचार करायचे. फॉरेन की
हा.
म्हणजे दुसऱ्या टेबलची प्रायमरी की. हा म्हणजे पुढे पुढे आपल्याला गेल्यावर कळतं की कॅन्डिडेट की पण फॉरेन की होऊ शकते. पण ते कॅन्डिडेट की कशी करायची, कसं काय रेफर करू शकते तो फर्दर पार्ट आहे. पण सध्या फक्त एवढं लक्षात ठेवा की दुसऱ्या टेबलची की की म्हणलं की प्रायमरी किंवा कॅन्डिडेट की, सुपर की नाही. ती मी
Okay.
एखाद्या दुसऱ्या टेबलमध्ये रेफर करू शकतो. ओके.
Okay. Now it is clear. Thank you.
नो प्रॉब्लेम. ऍक्च्युली नाव ओनली यू शुड गेट दोज कन्सेप्ट क्लिअर, बिकॉज की जर कळालं नाही तर मग तुमचा डेटाबेस शिकून काही फायदा नाही. त्याशिवाय दोन टेबल मधलं रिलेशन किंवा ती व्हॅल्यू इथं कशी आली, त्या व्हॅल्यूवर कुठलं रेस्ट्रिक्शन द्यायचं, कारण की रेस्ट्रिक्शन जर ऍड करायचं म्हणलं तर कीचा कन्सेप्ट खूप क्लिअर लागतो. ओके. आणि टेबल कुठलाही रिलेशन कुठलंही टेबल रेस्ट्रिक्शन शिवाय म्हणजे व्हॅलिड मानलं जात नाही. ज्यावेळेस आपण रिअल लाईफ मधले डेटाबेसेस तयार करतो त्यावेळेस कीज हा मेन पार्ट आहेच तिथं. ओके. नाव लेट अस मूव टू द नेक्स्ट, that is a schema diagram. Schema diagram. So schema, it means this is a structure, and diagram, it means how I'm defining the structure of a database. So here, just like in the ER, we are using square, that is rectangles, and relationship as diamonds. The same way in relational model also, we can give the graphical representation. So graphical representation is somewhat different. Yes, most of the part is same, but only some small differences there in the schema diagrams. So let us read these points one by one. A database schema, along with the primary key and foreign key dependencies, can be depicted by the schema diagram. So here, whatever our relational structure is there, or relational schema is there, or database schema is there, that can be given by the schema diagrams. So each relation appears as a box. In the entity also, we have seen this point, that every relation appears as a box, or every entity as a rectangle, with the relation name at the top in the blue. It means whatever the first part is there, that is the blue part, and the attribute listed inside the box. Yes, whatever attributes are there, we are listed into second part. And primary key attributes are shown as underline. Yes, primary key attributes we are showing as underline. And foreign key dependencies appear as arrow from the foreign key attributes of the referencing relation to the primary key of the reference relation. So here also the same confusion you will get clear. Primary key of reference relation, it means whatever the main relation is there, and foreign key of the referencing relation. So let us see how the schema diagrams are represented. So this is the schema diagram. So every relation, right now we will focus on, let us take department and instructor only. So here, this is my department relation. Is this figure clearly visible? Okay.
Yeah, ma'am, it is.
Okay. Yes. Here, department, this is my main relation, and department name, this is a primary key of the department, and this is a used as a foreign key in the instructor. So here we can see the arrow. Here, foreign key is there. The statement says that foreign key dependencies appear as an arrow from foreign key attributes, referencing relation to the primary key of reference. It means we are having arrow from referencing to reference relation. So the same is shown here. Here department name is a foreign key. From this I'm having arrow to the department name, into the department. Now this is my reference relation. This is my referencing relation. And here arrow is from this referencing relation to the reference relation. So here, as there are three rows, that's why this is shown somewhat to the lower side. Again, if consider course is my some another relation. Course it means a subject. So I was saying that this course belongs to department CSE. If I'm saying that database engineering belongs to the CSE department, then department name is a foreign key in this relation, and from this relation, this is a primary key of the department. Then the arrow will be from this foreign key to the primary key. Again, advisor relation also we have seen. So advisor, this is also shown as a relation. So advisor, this instructor is advising to this student. Then here we can see that there are two foreign keys are there. Two foreign keys. One is a student ID and another is a instructor ID. So instructor ID is from the instructor relation and student ID is from the student table. Then this is a primary key of the student. That's why the arrow is from referencing relation to the reference relation, or second arrow is from referencing relation to the reference relation. So there are two foreign keys are there. Okay. Again, prerequisite, there are also two foreign keys, teachers, that which instructor is teaching which subject. So here we can see that department is a relation name and there are the attributes listed here and primary key is being underlined. Okay, clear with this? So please have a look on this schema diagram. So this is the university database we will be using complete throughout our database engineering study. Only one example we have taken, and the same example we are going to repeat that for learning different concepts. So please have view on this. See the structure, which key is being referred where. Done with this? So, okay, let us revise what we have studied. So, only from the first chapter, first part, only this part is remaining. So, shall we cover this point or shall we cover this in the next lecture? Relational query languages. Only single part is remaining from the first part. Okay, let us cover that point also. Relational query languages. So, relational query languages, it means that here this is based on the relational model. So, query languages. So, let us see first a definition. A query language is a language in which a user requests information from the database. Here, if I am referring that I need to know which are the students who appeared for any NPTEL class, that information is available into database, but how to retrieve that information, the language or the medium through which database allows me to retrieve this, that is called as a query language. So in terms of a database, query language refers to a user request. That is, whatever my requirement is there, based on that I will request information from the database. For this purpose, whatever language we are using, that is a query language. So these languages are usually on a high level higher than that of the standard programming languages. So just like we are performing select or any other query, that's why these queries are much more higher level languages. Query languages can be categorized as either procedural or non-procedural. So procedural languages, it means that user instructs the system to perform a sequence of operations on the database to compute the desired result. So here, whenever we are saying the procedural languages, along with the request or along with the information needed, we are also giving how to retrieve that, or how to retrieve that information. Procedure is also given. So that's why this is called as a procedural languages. So procedural languages, it means that along with the data to be retrieved, we are also giving the procedure, which procedure or how to retrieve the data, that is also given in the procedural languages. And in non-procedural languages, user only describes what data is required, or desired data is required, without specifying how to retrieve those data. So in non-procedural language, a user describes the desired information without giving a specific procedure for obtaining that information. So that is the difference between procedural language and non-procedural language. Procedural language, procedure is given how to retrieve the data. In non-procedural, only what data is required, that is given without specifying the procedure. Procedural versus non-procedural. Non-procedural languages are also called as declarative languages, and the pure languages, which are it means when for the relational query languages are relational algebra, tuple relational calculus, and domain relational calculus. So these are the pure languages, and based on these models, other languages are based. So above three pure languages are equivalent in computing power. It means here which operations relational algebra can perform, all those operations will be done by the tuple relational calculus, and all those operations will be also performed by the domain relational calculus. Next, this in this chapter we only focus on the relational algebra, which is a non-Turing machine equivalent and consists of 6 basic operations. Okay, so regarding these 6 basic operations, we are having relational algebra and its operations. So select, project, union, intersection, many more are there, set operations, etc. So we will see those basic operations. So throughout this our lecture, we are using this university schema. So here, whatever underlines are there, these are the primary keys. It means, it doesn't mean that building and room number, there are 2 primary keys. No, this is a composite primary key. Each table will have always only a single primary key. There can be multiple candidate keys can be there, but only single primary key will be there. And if more than one attributes are there, it means that is a composite primary key. And if the same columns I'm referring to some another table, it means that will be called as a uh, foreign key in that table. So this is the university schema which we are referring throughout our study.
Ma'am, hello.
Yes.
Ma'am, can you give me,
Yes.
can you give the example of query which is non-procedural?
Query
Means which
non-procedural.
we are
Okay.
using.
In case of yes.
Means, ma'am, we are just
Yes, yes, go ahead.
we are just like writing the queries onto command prompt, like our SQL command prompt, just writing the queries like such kind of data
Yes.
we want, but we can't
Uh,
specify how to
uh,
retrieve it. So uh, what I think we are using non-procedural query.
yes, SQL is non-procedural, but SQL is based on the relational algebra, and relational algebra is procedural language. If consider, I'm saying that select star. Okay, I will take an example of the query here. Select star from department. Okay, this is my query. Okay, so execution of this query is that I'm saying that Select star, it means all the columns from department relation. That is the meaning. But how to do that? In background, my SQL compiler or interpreter will take the relation department, and then here I'm not writing any higher query with the where clause, etc. From the department, whatever the tuples it takes, then it means select star. Here also there is no filter for the columns, etc. And that's why it will display all the tuples. Then this becomes my non-procedural query. How to take the department table and how to perform the filtration, that is not given here. Here if I'm saying select name, okay, department name, okay, this is my requirement, department name from department, and I wanted to know that which department is there in second floor building. Okay, building, I will take this as building equal to consider second building. Okay, which department is there in the second building, I wanted to know. Okay, then here I'm specifying that here in this particular query, first it will select complete department. Okay, this department relation it will take, then it will apply this condition on that department name. It will choose only those departments wherever a building is taken as a second building. Here in the department relation I'm having three columns: department name, building, and budget. And my requirement is that I wanted to know the department name which are there in the second building. So if I'm saying that building is second, then my SQL interpreter will choose first department relation, then it will go for only selecting those values for which building equal to second building is there, and then only it will display only department name. Then third filter will be applied here. Third filter, that department name from department name, department name, that there are, even though five, there might be many many departments will be there in the second building, and those many departments only will be get displayed here. Yes, it is a non-procedural query language. How to select the department name, how to filter those tuple, that we are not bothering here.
Okay, it is clear.
Okay, so we are having this into much more detail, so we will study regarding this point in the next lecture also. So any doubt in the today's lecture? So today we have covered almost 5 points. So first we have studied structure of relational databases, that it contains table and it contains columns and rows. Columns are called as attributes, rows are called as tuples. Next we have seen the database schema, the overall structure of the database along with the schema of all the relations will be called as the database schema. Keys, three types of the keys we have, four types of the keys we have seen: super key, candidate key, primary key, and foreign key. Next, we have seen the schema diagrams. Schema diagrams, each relation will be represented as a box. Within that, relation name will be given in blue at the top, and then all the attributes will be listed. And wherever these attributes are primary key, underline those attributes. And if attributes are referring to the foreign key or attributes are foreign key, then we are giving that by using arrow from referencing to the reference relation. That is how we are representing the schema diagrams. And next, relational query languages. So there are three pure languages: relational algebra, tuple relational calculus, and domain relational calculus. So regarding these three languages, we will study into the next lecture. So any doubt in today's lecture? So please, all of you, give the attendance in the chat window. There are only 3 minutes remaining for the lecture. So if I go on taking the attendance, this it will take very longer time. Please give your attendance into the chat window. You all have submitted examination form? Okay, Jaydeep. Soon I will share an Excel sheet with you, which will be containing link of all the lectures. Actually, as last lecture I have taken on mobile phone, I am unable to record that lecture. So, except last lecture, remaining lectures link I will share with you.